Hi guys, it's the one and only maths favorite teacher. So on this session we'll be basically dealing with Kirchhoff's laws. So this electrical engineering question, they're saying calculate the current, voltage drop and the power through the load resistor R3, right? So one thing that you need to understand here, they showed us, I didn't show it, let me show it. They showed us these directions of the current, and then they said here is our I1, which is current number 1, then that is our I2. So the first thing that I'm gonna do here, before I can be able to solve this question, I must label my circuit, right? So we're gonna label this as A, B, C, D, E and F, right? So one thing that you need to understand here, we have our resistor number 1, which is 6 ohms. We're having resistor number 2, which is 10 ohms, as well as the road resistor that is represented by R3, there being 20 ohms. Now one thing that you must understand is that you must picture this in this manner. Now when you look at this circuit here, the direction of the current is going that direction, and then it enters here, right? And then also here, the direction of the current, it comes this direction, it enters there. So it means to say we are having current coming in the opposite direction like that, and then it enters there, and then it goes there, and then it splits just like that, right? So one thing that is very important is that we need to find the current here at BE. So for us to find the current at BE, we can get it like this. We can just say current, which is I1, right? So we can say current I1 plus, when we add it with current I2, let me write it here, current I2, it gives you the current at what? At BE, right? So it means to say you can write it and say therefore the current at BE is equals to what? It's equals to I1 plus what? Plus I2. Now it means that we are having a current that is going in that direction, which is going to be represented by what? Which is going to be represented by I1 plus I2. So that is our direction of the current. Now one thing that is very important there, you know that they want us to determine what? They want us to determine the current voltage drop as well as the power through the load resistor using Kirchhoff's law. Now one thing that we're gonna do with regards to now answering this question is that we need to follow what the question wants us to do, which is us making sure that we use what? Kirchhoff's law. So one thing that is very important is that we know that we are having two different types of laws for Kirchhoff, right? Which is Kirchhoff's current law as well as Kirchhoff's voltage law. Now Kirchhoff's current law states that in an algebraic, states that the algebraic sum of the current entering a point is equals to the algebraic sum of the current leaving that point. So that is Kirchhoff's current law. Then Kirchhoff's voltage law states that the sum of the voltage drop in a closed circuit is equals to the algebraic sum of the applied voltage. So when you apply Kirchhoff's law, we know that we're gonna consider, let's take our loop, right? So we're gonna consider loop what? Consider loop ABEFA. ABEFA. So that is the loop that we're gonna be considering, right? So as we are considering that loop, because it's very important to also take note of the loop that we are using, because most people, they make mistakes because they don't know the kind of loop that basically they must use, right? So you must know the type of loop that you are using, so that at least you know what you are going to do with regards to the direction of that loop, right? So as we are continuing, we're gonna choose the first loop, which is gonna be loop ABEFA. Now when you consider ABEFA, is this loop that I'm just gonna try to highlight here. A, B, E, F, A. So we're gonna consider that red loop. So on that particular loop, what are we gonna have? We know that V1, we're having V1. We know that V1 is equals to what? V1 is equals to what? Is equals to I1 R1, which is a resistor number 1, plus what? Plus, and then we're having we're gonna have what? We're gonna have I1 plus I2 as well, multiplied by R3, which is resistor number 3. Now we can write it as V1. We know that here we are having 7 volts, right? We're gonna say 7, it's equals to, so remember we are looking for what? For I, so it will be I1 right here, and then into, so when you check resistor number 1 here, we're given 6, so I'm gonna say 6 plus, and then this will be what? I1 plus I2 multiplied by what? Our resistor number 3. So when you look at the resistor number 3, there we are having 20, so it will be 20. Now if you write it properly, it will be 7 mathematically is equals to I1 times 6, that will be 6I1 plus, and then here it's one and the same thing with you now saying 20 times I1, that will be what? That will be plus 20 I1, then you say 20 times I2 plus 20 I2, and then from here you're gonna pair like terms. You can see that these two, that basically are like terms, right? So when you pair them together, it will be 7, it's equals to, so 6I1 plus 20I1, it will give you what? 26I1. So it will be 26I1 plus 20I2. So we're having 7 is equals to 26I1 plus 20I2. So that one on its own is going to be regarded as our equation number 1. So we're having equation number 1, right? And then as we consider now, we're going to consider the other loop. Consider loop what? Let's check. We're going to consider loop CB, CBE, CBE, DAC. So that is the loop that we're gonna consider. So let me show you this loop that I'm saying we must consider. Let's check loop C, B, E, D, C. So you must be careful for that. So here we are having loop C, B, E, D, C. C, B, E, D, C. Yes. So that is our loop. So that loop is the one that I've just highlighted, being the purple one there. So when we write that loop, remember we're having 12 volts. So it will be 12 volts is equals to what? It's equals to, we're having a I2. Because if this is I2 right here, it means to say also this I2 is the one that we're gonna be using, right? So it will be I2 resistor number 2 plus, and then when you check here, current is going this direction and then it enters there. It will find what? It will find current number 1 and current number 2, which is this one, together with resistor number 3. So it will be into I1 plus I2, I1, and then you say plus I2 into what? Multiply by resistor number 3. So that is what we are going to have there. And then when you now continue with this, when you now consider this, you know that here we're gonna have what? We're gonna be having 12 volts. It's equals to, now our I2 is unknown, so it will be I2 into, and then our R2, when you look at it on the diagram, is 10 ohms. So I'm gonna say 10 plus, so this is one and the same thing with us writing it like this. Let me show you guys. R3 into I1 plus I2 to make your work to be much simpler. Then you can say 12, it's equals to, so I2 times 10, that will be 10 I2, right, plus Now let's substitute our load resistor, which is R3, that will be 20. So it will be 20 into I1 plus I2, right? So here you're gonna be having what? You're gonna be having 12, it's equals to what? 10 I2, right? Plus, let's check. So it's 10 I2 plus, then now I'm gonna use FOIL method. So FOIL method, I'm gonna say 20 times I1 as well as 20 times I2 again. So it will be 20 I1 plus 20 I2. So it will be plus 20 I1 plus 20 I1 plus 20 I2. Let me double check. 20 is 10 I2, yes, plus 20 I1 plus 20 I2, yes. So we're gonna say 12, it's equals to, now when you arrive here, you pair like terms together. Like terms, these are terms which look alike. So we're gonna pair this and that one because they carry I2. But before that, we're gonna write here 20 I1, just like that, plus, and then when you add 10 I2 together with 20 I2, it will be plus 30 I2. So we're having 12 is equals to 20 I1 plus 30 I2. So that on its own is going to be representing what? Our second equation, which is equation number 2. So now we have our equation number 1. Also now we have our equation number 2. So with that being said, here we're going to say what? We're going to say multiply equation what? Multiply equation number 1 by 20. So when you say multiply equation number 1 by 20, it means to say we're gonna write equation 1 as it is. So it will be 7 is equals to what? 26 I1 plus 20 I2. So that on its own, we're gonna now multiply it by what? We're gonna multiply by 20. So when you say 7 times 20, it gives us 140. It's equals to, and then 26 I1 times 20. So it will be 520 I1, 520 I1 plus, and then 20 times 20, that is 400. So it will be 400 I2, right? So this on its own, it gives us what? Our equation number 3. Now we want to get our equation number 4. So for us to get our equation number 4, what are we gonna do? We're gonna say multiply equation number 2 by 26. So when we say multiply equation number 2 by 26, we're gonna write equation number 2 as it is. So it's 12, it's equals to what? 20 I1 and then plus 30 I2. So we're gonna multiply it by what? We're gonna multiply it by 26. So 12 times 26, we're going to 312. Write 312, it's equals to, then you say 20 I1 times 26, that will give you 520 I1, right? Then plus, we say 30 I2 times 26, it will give you 780 I2. So this will be equation number what? So this is equation number 4. And then from here, we're gonna say what? We're gonna say equation number 4 minus equation number what? Equation number 3. So we're gonna take our equation number 4, we subtract equation number 3. So let's look at equation number 4. So it will be equation number 4, the entire equation here, this one, subtracting equation number 3, which is going to be the entire equation, this one right here. Do you see? So you're going to subtract those 2 equations. Now let's try to do it here aside to do the subtraction. So So with that being said, now at least you know which equation we are subtracting, right? So since we are saying equation number 4, the bottom orange one, subtracting equation number 3, the top orange one, so it will be 312 minus 140. So 312 minus 140, it gives us 172. So it gives us 172 is equals to, then 520 I1, subtracting 520 I1 is the same as 0, you leave it. Then you say 780 I2 minus 400 I2. So 720, let's check, 720 minus 400, 780 minus 400, we're getting 380. So you're gonna write 380 I2. So due to space, I'm gonna write it here. 172 is equals to what? 380 I2. And then you divide both sides by 380, guys. You divide by 380 because Mess says what you do on the left hand side, also do it on the right hand side. And this cancels that. Here you are left with 172 over 380 is equals to I2. You can write it like this, I2 is equals to. Then when you divide the 172 divide by 380, it gives you what? It gives you 0.453. So this is current, it must be in amperes, right? And then after that, we are now having what? We are now having current number 2, which is I2. So we're gonna simply say substitute I2 into equation number 1. So when we're saying substitute I2 into equation number 1, we're gonna basically write equation number 1 as it is. So equation number 1, remember it's 7. So we're gonna write it here. So remember that it's 7. Still trying to find this. So we're gonna write 7. It's equals. So this is our equation number 1. 7 is equals to 26. 26 I1 plus 20 I2. So we're gonna say 7 is equals to 26 I1 plus 20, and then in the place of I2, since we got I2 being 0.453, you write it as it is. So it will be 20 into 0.453. Then it will be 7 is equals to 26 I1 plus, so 20 times 0.453, it gives you 9.06. So write 9.06. So here it will be 7. We take that positive 9.06 on the other side, it changes the sign to become negative. So it's going to be minus 9.06. It's equals to what? 26 I1. So this one, when you subtract, it's minus 2.06. It's equals to 26 I1. You divide both sides by 26. So this cancels that. Then our I1. So our I1, we're gonna get what? We're gonna get a negative 0.079. Negative 0.079. So it will be amperes. So here you know that current, it can be negative. So you'll say therefore I1 is equals to what? 0.079 amperes. So that negative, what does it represent? It simply represents the direction, right? So it will be therefore I1 is equals to 0.079 amperes in the opposite assumed direction. So in the opposite assumed direction. Right? So that's how basically we solve this. But remember, we are not yet done, because this question, when you picture it properly, they said they calculate the current. Now we have the current, and then the voltage drop of the voltage drop and the power through the load resistor. Now to those who didn't know, this will become our load resistor, right? So for us to calculate the voltage drop through our load resistor, we are having our load resistor being 20, right? So we must calculate the current through this load resistor, that is represented by what? By I1 plus I2. So here we are having I1, we are also having I2. So the current through our load resistor, which is, I'm gonna representing it as IB. So IB, it's our current. It's our current through the load resistor. So this is our current through the load resistor, represented by IB. So I know that IB, which is current through the load resistor, is equals to what? It's equals to current number 1 plus current number 2, right? It's equals to current number 1 plus current number 2. So our current through the load resistor is going to be equals to, so current number 1, we are having negative 0.079 amperes, plus our second current, we got what? 0.453 amperes. So I'm going to say current at BE, which is going to be represented as current at our load resistor, is equals to, so the final answer here, you get 0.37374. So it's amperes because it's representing the current. So this one is what is, it's our load current, right? So that is gonna be our load current. So this one on its own is gonna be representing our what? Our load current. If you didn't know, it represents our load current. Now we are having our load current, right? And then since we are having our load current, we're gonna calculate the voltage drop. After calculating the voltage drop, then we calculate the what? We calculate the power. So we know that a V drop, which is gonna be the voltage drop, it's equals to what? It's equals to IBE, which you know that IBE is the current through the load resistor, multiplied by R. Let me just say R load, which is gonna be representing our load resistor, just like that. So we're gonna be using this formula. Let me write it here. So it's gonna be a V drop, it's equals to current at BE multiplied by R load, which is the load resistor. So our voltage drop that they are looking for, it's equals to current at BE, we got 0.374. So you'll say 0.374 multiplied by our load resistor, which is what? Which is 20 ohms that we are having on the circuit. Then we're gonna say V drop, which is the voltage drop, is equals to, when you multiply 0.374 times 20, it gives you 7.48. So it's gonna be 7.48 volts, because that represents our what? That represents our voltage drop. And then with regards to, so this can be Roman figure number 2, and then now I'm gonna do Roman figure number 3, because here they wanted us to calculate the current, which we did, the voltage drop, which we just recently got, as well as the power. Now for you to calculate the power, you must understand that power is equals to VI, right? Also power is equals to what? Power is equals to I squared R, as well as also power is equals to V squared over R. So I'm gonna use either one of these, or you can use all of them. At the end of the day, you're gonna get the same answer. So let me show you in 3 ways. So let's start by using the same one. P is equals to what? P is equals to VI. So P is equals to, so our voltage drop, we recently got 7.48. So you can just say 7.48 multiply by the current at IB, which is the current through the load resistor, which is going to be 0.374. So it will be 0.374. Let's see what is going to be the answer. So it's going to be 7.48 multiplied by 0.374. So that is 2.798, right? So it's going to be 2.798. Power is measured in watts, right? So that is option number 1. And then with regards to option number 2, I'm going to use the second formula for power. So power is equals to V squared over R over R. And then in this case, what am I going to get? So our V, remember, is going to be the voltage drop, which is, we got what, 7.48. You're going to write 7.48, then you square it all over. Our load resistor is 20. So the final answer that you're going to get 2.798 watts. So that is option number 2. And then also the one who's going to use the last option, which is option number 3, you're still going to get the same answer, because at the end of the day you are using the formulas for power. So another one will say power is equals to what? I squared R, right? So power is equals to I, remember, it's our what? It's our load current, which we got 0.374. You square it, remember, it's this one. 0.374 is this one, and then you square it, right? And then you multiply by the load resistor, which is 20. So you're gonna get what? 2.798 watts. So it doesn't matter whether you used this one, it's still gonna be correct, or that one, or this one. At the end of the day, you're gonna get the what? You're gonna get the same answer. So guys, you must make sure that when they want the power, you can use any formula that you have there. And then one thing that is very important there is you now using what? You now using the rules of Kirchhoff, or using Kirchhoff's laws, in order to do what? In order to find the questions that they want there. So that's how basically we deal with this, guys. It's a one and only favorite electrical engineering tutor. Stay tuned for more.